Good evening, everyone. My name is Snezhana Kristeva, and I'm one of the curators of the Coming World exhibition. I'm very happy to see you all over here, though it's Friday night. Thank you very much for coming. And I won't take a lot of time now. I just want to say a couple of words. Susan Schuppli, who we have a great honor of listening to tonight. She came to Moscow not only to take part in the public program, but she also came to us to participate in the so-called weekend department. That's the educational program that we started a couple of years ago, and we continued with every exhibition project. And this project includes, apart from public talks, also workshops for Saturday and Sunday. It's a program for a selected number of candidates who work with our mentors, with the artists. We focus on artistic research. For us, it's a very important program, really. And hopefully in the future, you will also apply for this program. Hopefully we'll see among the participants. That's it, really. Thank you very much. Susan has visited Moscow a few times already. It's not her first time here. Hopefully. She says the weather this time is much better than the previous time, and the previous time she visited Moscow in January. So I won't take any more of your time. So Susan, thank you very much.
Just a moment.
I also forgot to say something. The public talk will take around 60 minutes, and then we'll have around 15 or 20 minutes for the Q&A session. So please think about the possible questions. Susan said that she was going to show a lot of videos, a lot of visual materials, so it won't be just talking. It will be a dynamic workshop, really. Thank you very much. Susan, the floor is yours.
Thank you very much for the invitation to come and share some of my projects and ideas with you. Also, it's terrific to be here within the context of the exhibition, which is a very kind of provocative thesis for an exhibition. I obviously have a piece in the exhibition, so I'm not really going to talk about that. But I've called this presentation Earth Evidence. And the reason for that is my larger practice has been organized around the concept of the material witness. So I've been trying to look at the ways in which materials record, capture, carry traces of external events. And through a series of intercessions, they could be kind of forensic or in this case also sort of artistic aesthetic, try to look at the ways in which materials can be sort of scrutinized and unfolded to produce some sort of kind of history, sometimes even a counter kind of narrative. I'll try and talk reasonably slowly so that there's no kind of issues with my sort of rambling, which I'm sometimes prone to doing. But the notion of evidence has also, of course, become very, very crucial under the conditions of climate change and global warming, because one requires evidence in order to make a political claim and to influence, for example, environmental policy or political kind of decision making. It's not enough to say that things are changing and it's clear if we look all around us. There's a kind of fundamental requirement for the production of evidence. And I'm going to end tonight's presentation with clips from a new project that I've just completed for the Toronto Biennial of Art called Learning from Ice. And the first part of that project is a documentary about ice core science. So ice cores are probably the most significant carrier of information around our warming planet that one literally cannot kind of argue against, because in those ice cores is actual air from 800,000, almost a million years ago. It's not a tree ring that is an indirect mode of measurement. The thing itself is captured by the materials. So I'd like to use the presentation tonight to somehow also make my way towards my most recent work and give you some insight into how I arrived there. Behind me is the electromagnetic spectrum, and we have the very small area, as you can see, in the somewhat in the middle, which is the kind of area of wavelengths where, where there's a kind of regime of visibility that humans can actually perceive. And this will become really kind of important in the projects, because so many of our current contemporary violations, and also historical, but many environmental harms are not organized by human modes of perception. They may take many years to enter into the water table, into biological systems. Their effects don't necessarily produce a kind of visual regime. So I wanted to begin with this kind of provocation of this spectrum, which gathers a whole set of kind of wavelengths, only a very small portion of which is actually that which humans can, as I said, perceive. And the American environmentalist Aldo Leopold, he once made a really, I think quite a provocative comment. He said that we can only be ethical in relationship to that which we can see, that we require a kind of an image, a representation, something that produces visibility of injustice in order for humans to act and intervene. And I've thought about that for a long time, certainly, and thought about the challenge that sort of ethical kind of provocation that he raises poses for situations when the harms are environmental, toxic. We're talking about things like pollution, etc. I'm going to jump into now. What I'm going to do for the remainder of the presentation is just walk through some projects, and many of them are video clips. They're by and large in English, so I apologize for that, but you'll see that the soundscape is also an important carrier of meaning for me as well. So as I said, we're going to focus on the ways in which evidence for events is produced by, say, ecological systems in tonight's presentation. And I wanted to begin with this kind of paradigmatic image of the Geiger counter at Chernobyl. And for those of you who know my work, I've spent a long time producing projects that deal with radiation and nuclear kind of legacies. So the Geiger counter is a technical probe that produces that very familiar, acoustic kind of signature of radiological kind of contamination. But it's a highly localized kind of instrument, whereas, and this is the exhibition in the museum, which I produced, called Decay. So it was one of the many kind of projects that I've developed that have tried to kind of grapple with nuclear disasters and accidents. Another project that I did is a project that responds to the accident at Fukushima Daiichi in Japan. And what we see in this image is a new kind of technical probe, a gamma sensor. And this is an image where we're looking inside the Fukushima Daiichi nuclear power station after the accident took place. And what's so particular about this gamma sensor, it allows scientists to track radiation contamination in very large environmental sort of systems. I have a little clip of a group of scientists that have used this outside in a sort of forest valley. And just to give you so what we have is a CCTV, that is to say a video camera with a gamma sensor superimposed, and obviously it's calibrated so those red pixels would be areas of, high contamination, whereas areas where there's no pixelation at all would actually be much lower. And this is what I said, radiation contamination is extremely localized. So the corner of the table could be contaminated, but over here it may not be contaminated at all. And produces a very difficult and challenging spatial condition to investigate. So I'll just play a little clip. This is actually from Japanese television, where these scientists take this gamma camera into the field. So just so you can see how it works, because I tried to use this in one of my projects.
One scientist involved in these investigations is Satoshi Mori. Mori and his team use a special camera that can show a visualization of the radiation dose. The areas with the highest levels appear in red. It's clear the amount of radiation near the ground is particularly high. Hotspots with exceptionally high levels of radiation are scattered throughout the forest.
So I just wanted to show you that, because part of my work is also tries to look at the ways in which new technological systems are being developed to, in some way, sense these different kinds of contaminants, new systems of measurement, etc., new systems of investigation. And so I went to Toshiba. Toshiba are the people that produce this in Japan, in Yokohama, and I asked if I would be able to rent or borrow this camera, and the response was, of course you couldn't possibly take this camera. It's a highly sensitive piece of equipment. You have no specialized training, and there's only, at that time, 2 of them in the world. So of course I got the point, but nonetheless, I decided, well, I'm still going to actually work with that sort of, that signature of the gamma sensor in the project that I produced. So I had to sort of, in fact, I had to produce my own kind of gamma sensor graphics, if you will. And I'm just saying that because that would be very different than the kind of work that I did previously, say, when working with Forensic Architecture, which is a human rights agency, where they wouldn't be inventing things to tell a kind of story, but I give myself certain permissions when I'm making artistic projects. There's a story I want to tell, and I need to develop a visual language to tell that story. So I produced a trilogy called Trace Evidence, and it looks at 3 instances of nuclear evidence. We're going to see 2 clips from 2 of the chapters. So I'm not actually going to show you a clip from the chapter that deals with Chernobyl. In that chapter, I actually looked at the ways in which radioactive isotopes, especially cesium-137, were found at Forsmark in Sweden, and then the kind of political debate that ensued. The first chapter is called Geology, and it takes place in 1972 within the context of uranium mining in Gabon in Africa. So, as I said, I'm just going to show you little clips throughout the evening.
Uranium mining continued throughout southeastern Gabon until 1999, when the economic viability of extraction shifted. Oklo's deposits only lasted until 1985, after which time its waste rock was left to languish. Futile efforts to curtail uranium dust and the extensive leaching of contaminants from the region's many tailing ponds led to the damming of the Mutembe River. Trace evidence of its ancient nuclear legacy has since reappeared, but not as a dangerous latency attributable to the cosmic alchemy of early Earth, but rather to that of industrial mining
For 40 years, Comuf, a subsidiary of the French nuclear giant Areva, mined uranium in southern Gabon. The operation has had serious consequences for the health of the workers and locals. Many former miners, both Gabonese and French, have died of lung cancer. Under pressure from NGOs, Areva opened medical clinic last October, but the staff here don't all have the training or resources to properly diagnose diseases linked to uranium mining.
Ça fait plus de 30 ans. Plus de 30 ans qu'on a ce problème.
Ça fait longtemps, depuis que Comuf existait.
A legacy of colonialism and unnatural resource extraction expressed within the damaged ecosystems of the region and the cellular defects of mine workers and local inhabitants. At Oklo, a lethal archive once etched into its ancient geology now re-emerges within the biopolitical strata of matter.
Cette carrière aujourd'hui, elle est remplie d'eau. Et lorsqu'on a démantelé l'ancienne usine de la nouvelle, tous les déchets ont été rejetés. Donc, tout ce qui a servi à la construction de l'usine, les fers, les engins de mine, tout a été jeté à l'intérieur de cette carrière.
Tous les déchets venaient des usines. Tous les travaux de la digue ont duré au moins 2 ou 3 ans, parce que c'est bien avant la fermeture de l'usine qu'on a fait ça. C'était pour faire disparaître les traces.
So in that short clip, it introduces the legacy of uranium mining under the colonial, in particular, France was one of the most active colonial powers that was utilizing its colonies for purposes of resource extraction, but then certainly not actually following up with any sort of remediation or cleanup, et cetera, et cetera. So there's a kind of really powerful legacy of biological consequences for those colonial activities. And so a very significant part of my practice has been trying to look at questions of accountability on the part of states or institutions or corporations for the harms and the violations that they produce, in part because our legal systems are incredibly hampered by anything where it's very difficult to link cause and effect directly. The law has an incredibly difficult time if A and B are not directly connected in a very kind of legible fashion, but we know that contaminants move through environmental systems. Radiation in particular enters into all kinds of materials and has an extreme kind of latency of many sort of years. So the notion of accountability for actions was very important in the first chapter. The clip from hydrology looks at a different facet of the debate, which is, in this case, it's the delay between the time of the accident, the time of the event, and when those materials actually surface somewhere else. And in the case of Fukushima Daiichi, it took 5 years for those contaminants to move through the Pacific Ocean and make their way to kind of Western Canada. So that temporal gap is also something that I've been exploring, and it's part of the piece Delay, Decay in the exhibition here, which looks at that 1920-day gap in the former Soviet Union between the time of the accident at Chernobyl to when it officially is made sort of public by Mikhail Gorbachev. So let's look at hydrology. This is webcam footage, and it's the only footage from the accident, so it's blurry, low res, and silent.
The release of radioactive materials into the air and water had begun. While Chernobyl's fallout would eventually spread across extensive tracts of arable land throughout Europe, Fukushima's contamination seems to have traveled further still, crossing some 7,600 kilometers through the vast microbial channels of the Pacific, reaching the western shores of British Columbia many years later.
Scientists say that traces of radioactivity from the nuclear accident in Japan 4 years ago have washed up on Canada's coastline. It's the first time they've detected materials from the accident in North America, but they say the amounts don't pose a threat to living creatures.
So there we see the gamma sensor appear as a kind of superimposition, but also the utilization of sound. So I've often tried to use sound to make the environment somehow, to denaturalize actually environments. So a lot of the sort of filming I've done, these environments, there's nothing necessarily extraordinary about them, but they carry this kind of latency, this sort of lurking menace, if you will, that's not completely, it's not visible. It's not something we can necessarily smell or, but we might be able to kind of sense it in some way. So I've used sound to sort of try and help push that kind of conceptual argument along. What's quite interesting with the events of Fukushima Daiichi is there is a trial, the Fukushima Trial. It's still happening right now. So it's a very different legal trial than was the case in 1987 with Chernobyl, which only found, several sort of lower level engineers, officers sort of responsible. And that trial, of course, as I'm sure you know well, was very, very controversial because there was no state accountability for the accident at all. So this is a little bit different in the Japanese context. This is now many years later, where the three top bosses of TEPCO, the Tokyo Electric Power Company, those three men on that protest, on that activist poster, those men have been charged and are facing facing the courts. It's a question as to whether they will actually be found guilty, and in all likelihood, they will not be found criminally guilty. What tends to happen is that corporations, when things go wrong, they pay damages. They pay monetary claims. And this is a huge problem for communities that are suffering or that are trying to, that are dealing with injustices, and the law cannot provide any sense of kind of justice, because all it can sort of do is, and at least that's within most legal systems that I've sort of worked with, environmental harm tends to be met by a financial payout, but rarely are those CEOs and directors of these factories and power plants, et cetera, they're not going to land in a kind of jail cell anytime soon. I want to turn my attention now to it's a different example, but where there was quite an interesting kind of legal strategy that occurred, which in some way was a response to the kind of limitations of corporate liability in the face of kind of environmental disaster. And this is not an animation I made, but the project dealt with the accident in the Gulf of Mexico, the Deepwater Horizon deep drilling rig managed by BP, that is to say British Petroleum, off the shores of the United States. It's the most, obviously, it's the biggest sort of oil spill in the history of the planet. But I wanted to just bring up that animation because that blue dot, that blue square rather, that's the BP, that's their drilling rig, and it was a test rig. But those dots, and this animation only goes up to 2005, there's some 3,000 oil rigs in the Gulf of Mexico. You can see that whole water system is completely densely populated with all of these rigs. So what we're seeing in effect is a whole kind of potential series of accidents yet to come. But what was interesting in particular, what I wanted to focus on in particular with this was two things, was sort of legal and aesthetic kind of agency. So British Petroleum was very aware of the kind of public response that this kind of large-scale accident would bring about. And so they worked very, very hard to control the media. So access to the accident site. So the only images that we saw tended to be these kinds of official images. This is produced by the American Coast Guard. I produced an installation last year at the Sculpture Center in New York, and I tried to look at all of the different sort of the ways in which media was organized around this event. So on the wall, on that brick wall, is a large photograph, and it's an image that was produced by this activist organization called Public Lab, and they allowed me to use their image and blow it up. And I'll show you, normally they produce photographs that look like this, and what this is a camera attached to a balloons and kites, and they fly these cameras. They were flying these cameras off the coast of Louisiana to try and produce some sort of images of this oil spill that was moving across the surface waters of the Gulf. Because there was a total media ban, you weren't allowed, there was no like helicopters that could fly over this space. You weren't allowed to enter into the Gulf with your own, say, boat or anything like that. So Public Lab emerges as this DIY activist group developing other systems for producing kind of aerial surveillance and documentation. And the reason that image is so unusual, it's just hundreds of little rectangular images put together and then geolocated on Google Earth, in fact. One of the images we did see was the underwater gushing of this sort of spill. So that was actually images that we as in viewers could look at online every day over the many, many, many months where there's various sort of efforts to try and cap this spill. These are two aerial satellite images made by the Landsat satellite, which is an Earth observation satellite. So what we see there is, they're called false coloration, but what that strange sort of kind of like tentacular, the tentacles that you see, that's in the sort of pink and purple image over, that's the oil spill coming towards sort of land. And then on the other side, there's another image, and you can see, in that case, the oil is the it's the more sort of whitish areas. So they produce these false color kind of satellite images to help them sort of read the difference between terrestrial and aquatic space. But those images were in the exhibition because BP, British Petroleum, could not stop a satellite image from moving across the globe, in this case, the Gulf of Mexico, and taking kind of images. So this is a completely automated image system, so it circumnavigates the planet, taking kind of, it does it covers the entire planet every 16 days. So these images, which are open source, which you can download, you can really see the ways in which that oil is moving across the Gulf. But of course, what we see is just a fraction of what is actually, what's actually sort of happening. So BP couldn't control this. They couldn't control the leak. They couldn't contain the leak. They tried to contain the news and media cycle. And but the one thing that I decided to and this might, I hope this is going to make sense. This is just a little composite I put together for the purposes of the talk tonight. But in Ecuador, in South America, the country of Ecuador has a very unique constitution that allows nature to make a legal claim. It's called a Pachamama Constitution. So Ecuador filed a legal claim against BP on behalf of the rights of the sea. And Ecuador can do that because they're a signatory to the International Criminal Court in The Hague under the Rome Statute that allows them to, they have the possibility for prosecuting crimes that did not occur in their sovereign space, and that's called universal jurisdiction. Canada has the same thing. The United States does not. So if you have a legal system that abides by universal jurisdiction, it means that you can prosecute crimes that didn't necessarily happen in your jurisdiction, because the reason being that sometimes the crime might happen in another state where there's no kind of legal framework in place that is actually operative. For example, we see that a lot, say, within post-ethnic conflicts and wars in moments of transitional justice. But but to simplify things, so Ecuador filed a legal suit against British Petroleum on behalf of the rights of the sea, and unsuccessfully, ultimately, in the end. And it was a very innovative legal strategy because they asked BP not to extract basically to keep in the ground the same number of oil, millions of, I think it was like 63 million barrels of oil that had leaked into the Gulf. They said that was their demand. It wasn't financial, it was to cease operations for an equal kind of period. At the same time, I wanted to argue as well that the one media agent that had been entirely overlooked was the oil spill itself, because if you're a scientist working on hydrocarbon atoms, you actually call that, when hydrocarbon atoms, that is to say oil molecules, interact with water, they produce something technically that scientists call a film. And that's because of the ways in which light moves through water and molecules. And so it's really kind of like a proto-photographic or proto-cinematic system. There's lots of examples, like chlorophyll in plants. There's lots of examples where there's media before media. There's media systems in natural environments. And so I was arguing that if nature can have legal agency, then perhaps it could also have aesthetic agency. So arguing that the oil spill was documenting its own damaged condition and producing a kind of representation, if you will. So I'll play a 2-minute clip where we hear a little bit from the lawsuit and then also from the simulation. And so this is it's an image entirely made by releasing millions and millions of particles in a computer. So it's not a representation, it's an image that is constructing itself computationally. So I thought that was sort of the best, perhaps, analogy to the argument I was trying to make.
Quito, Ecuador, 26th of November 2010. The Honorable Secretary General Constitutional Court of Ecuador. Lawsuit on behalf of the rights of nature under the principle of universal jurisdiction. Under the principle of universal jurisdiction, we, Vandana Shiva, an Indian national, member of the Research Foundation for Science, Technology and Ecology, Ana Luz Valadez, a Mexican national, member of Desarrollo Alternativo, Diana Murcia, a Colombian national, member of the Instituto de Estudios Ecologistas del Tercer Mundo, Blanca Chancoso, a Quichua Ecuadorian national, member of Ecuarunari, Cecilia Cherres, member and president of Acción Ecológica, Nimo Basi, a Nigerian national, member of the Oil Watch Network, Delfín Tenesaca, a Quichua Ecuadorian national, member and president of Ecuarunari, Alberto Acosta, an Ecuadorian national, and Líder Góngora, an Ecuadorian national, member and president of Sea Condemned, hereby submit, in defense of the rights of the sea, understood as an integral part of nature, which the Ecuadorian Constitution of 2008 recognizes as a subject of rights, and which we recognize as a giver of life, of which we form part, the present lawsuit filed under the principle of universal jurisdiction against the transnational corporation British Petroleum plc, headquartered in the United Kingdom, as the responsible party for the environmental disaster that struck the Gulf of Mexico on the 20th of April 2010.
Yes, so if you went into the gallery, you would never experience the piece in that way. You would have to put on the headphones. If you went in, you would just have this sort of more ambient sound, and then if you put on the headphones, it would give you, in effect, a different audio track to the installation. And I was, of course, interested in the legal case, but also in some way, law also produces a very technical, it's a very specific kind of language that has a certain kind of technical kind of nature. So I also thought the language of law had a sort of an equivalence, if you will, to the kind of language of technology. And I've subsequently used some of those stills from that video in a series of billboards and a project in Vancouver. I'm going to move to really, I guess, my last two projects, because I think because they're quite linked, and they've helped me. They've helped me sort of understand the kind of my current kind of project that, as I said, is called Learning from Ice. And this is through an organization in the Netherlands called Sonic X. I was invited to run a workshop with students in the Netherlands with a group of climate scientists who work specifically on studying atmosphere, in particular clouds. And it's called the Cabao Experimental Site for Atmospheric Research. And at that site, which is, it's in effect, it's an open air laboratory. And, I would say that the Gulf of Mexico was turned into an open air lab. It was basically, British Petroleum ran a vast uncontrolled experiment in the Gulf of Mexico. They had no kind of risk or disaster management kind of plan in place. But in this case, we have a different kind of open air laboratory. This is a tower that's 213 meters high. It has a lot of different, lots of different kind of equipment on it, radar, different kind of sensors and probes, et cetera, to study the atmosphere. So there's a small elevator that you can go up in the middle of that, and I went up that, and then was just using that as one of the ways in which to sort of film the site. But what was the way that this project unfolded, it was actually I produced a 35 millimeter vertical film, and this is the sort of premiere of the film. So this is the way it was screened. And there's a small sort of subculture of filmmakers that make vertical films. And so when I was asked to produce this commission and make a 35 millimeter vertical film, it made sense to focus on this this particular site in the Netherlands because it has obviously such a strong kind of vertical feature. But the scientists were also really keen to be involved. And so it was the kind of moment that I worked not so much with lawyers anymore, but worked very closely with a group of scientists and documented their kind of practices and was really looking for moments where in the worlds of climate science and the world of, say, cultural production, sort of those moments where those two worlds sort of intersect and meet. And in particular, with this project, they use a lot of acoustic instrumentation to sample the clouds, to sample the atmosphere. This is just an image of the actual movie projector that they had to build in order to play these 35 millimeter films because they're made, you produce an anamorphic frame. So the projector then opens up this frame. So the projector has to be situated at the midpoint of the vertical kind of screen. And then, then the sort of projector will then expand and extend the kind of image. So, it was really kind of fun to be part of this kind of like whole kind of experimental sort of film community for a while. And but for the purposes of the talk, I usually give artist talks and lectures in spaces with horizontal screens. So I've made a couple of horizontal clips. So they're not going to give you that same sense of sort of vertigo, but at least will give you some sense of what was at stake in the project. So I have two clips from atmospheric feedback loops.
Noise is seen as a distortion. So we have thermal noise in the receiver itself, so that's the electrical noise generated by the instruments themselves. But we also have noise from the outside, so if you do a measurement, it's not only the cloud producing signal, it's also other things. A bird might produce a signal, an airplane might produce a signal. That's noise to us. When you talk about noise in this concept, a signal in comparison to noise, then noise is just something we don't want. On the other hand, if you do a pure measurement, then what you mainly measure is pure noise. Because if you look at the unprocessed data coming from the clouds, it's like noise. And we use our processing to get the signal, the data, out of this noise. Because it's hidden in there somewhere.
So Herman Rauschenberg, the scientist, he's saying a lot of things that really resonated with me. Clouds are noise. He's looking at the signal propagation properties of these atmospheric systems. He's really studying these environmental or ecological systems as forms of media, as materials that generate data sets and consequently kind of information. So he's already translated, as most contemporary climate scientists do, the ways in which they actually look at these kinds of ecological systems really is as forms of media. And I showed you that piece about the sort of oil spill in the Gulf of Mexico. So there's this very strong correlation between the understanding these kinds of understanding environmental systems as forms of technical media. And the degree to which that's the case was actually, I have to say, quite sort of surprising to me. But the scientists in this, at César, this site in the Netherlands, also kept mentioning the German conceptual artist Joseph Beuys. And so I'll play the final clip of the film for you, where they elaborate upon this sort of comment that Joseph Beuys made about Dutch light.
A story is repeated here at Cabao. The artist Joseph Beuys once theorized that the unique atmospheric properties of light, which had inspired Dutch painters since the 17th century, had disappeared with the land reclamation projects of the 1950s. As post-war modernization began its terraforming operations throughout coastal regions of the Netherlands, the air was said to have lost its refractive shimmer due to the diminished number of water molecules carried inland by prevailing winds.
We use a painting from the 17th century landscape painter Jacob van Ruysdael. In fact, this is what he painted, the Dutch skies. Well, without knowing it, he recorded all the complex things about atmospheric research that we're studying.
The scientists conducting research here are recording even more dramatic changes as atmospheric feedback loops between land, sea, and air reveal long-term amplification of climate change signals. Terrestrial, aquatic, and atmospheric mediums have been forcefully remixed, creating radical new forms of unnatural media.
So in that little clip there, the scientists, they mentioned two sort of cultural producers, Joseph Beuys, who said that, the air, the Dutch light had disappeared because obviously with the polders and the expansion of the Netherlands into the sea through land reclamation, villages are much further away from the sea, and therefore there's a lot less moisture in the air. So light is being refracted differently because there's less water molecules, as was said. But also the Netherlands has a very kind of rich history of landscape painting, and so this became a kind of crucial, I say, bridge to the final project I want to show you this evening, is because the scientists are using what they call data proxies. They're using these art historical works, these landscape paintings, to understand something about the ways in which the skies looked in the Netherlands in the 17th century. And this is really, really important because almost all instruments for measuring weather and climatic conditions were invented in the 19th century. But if you're wanting to build the global climate model, which is what scientists are doing, they want to understand atmospheric and they want to understand climatic change over hundreds of thousands of years. Well, how do you do that? You didn't have technical probes. You certainly didn't have image making practices like photography or the thermometer, but we have things like tree rings. So you can measure precipitation by measuring kind of tree rings or ocean sediments or stalagmites in caves. We have these materials that can be analyzed to give us some sort of insight into temperature and precipitation. But those things are indirect. A tree ring isn't, it's an indirect way of measuring precipitation. It's not a thermometer. And so in the same way that a painting is an indirect way of maybe understanding or speculating about what the atmospheric conditions in the Netherlands over specific areas where these painters made these outdoor landscape paintings, they might have some insight. Of course, all of this material, whether it's a tree ring or whether it's a painting or a farmer's almanac, where they're talking about harvesting of grapes et cetera, all of this material has to be translated, and it has to be evaluated and translated and then plugged into the kind of contemporary global climate model. So building that model requires that scientists look at a lot of cultural artifacts. They cannot simply look at technical scientific materials. They actually have to look at a much wider range of things in order to try and have as rich and as detailed a model possible. This is where ice cores come in, because ice cores are so crucial to building this climate model, because in ice you have air bubbles, and those air bubbles, unlike a tree ring that's a proxy, that air is actually from 800,000 years ago. It contains the CO2, methane, it contains atmospheric chemistry, and if to extract the information out of those air bubbles, it's very difficult to argue against the fact that the sort of evidential archive of ice cores, when it's very difficult to argue against the information that they hold, because you can produce a record of CO2 levels or methane that goes back now almost 1 million years, certainly 800,000. And so you can see very clearly that there's a kind of very dramatic spike with the when fossil fuel emissions come along. So ice cores are incredibly kind of fascinating for that purpose for me, because it's a kind of planetary archive. It's material that captures events from a long time ago, but also interestingly, ice cores are also being used to do all kinds of other things. So they're using the analysis of lead in the ice core record. So historians of lead smelting people who are studying, for example, the Roman Empire, can read the decline of the Roman Empire through the decrease of kind of lead smelting, because the Romans did a lot of smelting of lead through coinage and sewage systems, etc. You can read like the Black Death so you can read epidemiological kind of data. Every atmospheric nuclear test is recorded in the ice core record. So it's kind of extraordinary material. And, so I embarked on this kind of multi-year project called Learning from Ice, the first part of which is myself working closely with ice core scientists, both in Canada and the US. And then next year, I'm going to work with a group of Inuit youth, young people in Nunavut, in the sort of far north of Canada. So the project is much more about the circumpolar kind of north, and looking at the ways in which different kinds of practices, from indigenous, say, oral traditions, the ways in which indigenous communities are responding to environmental change, the ways in which scientific communities are working in the north, so it's going to be a kind of very multifaceted project that looks at all of the different ways in which knowledge of these changes are being registered by materials, by communities, and then sort of entering into various kind of public forums. So what I thought I would do is just show you 2, maybe 3 clips from this project. And what I've really tried to do differently is kind of make a break with my sort of extensive use of voiceover narration. So in this case, I had all of the scientists, they were just wearing radio mics. And so I really wanted them just to work and do their daily kind of practices with ice, and really have them sort of be speaking and having them engage with the materials, rather than me always telling the viewer what was sort of at stake. I do a little bit of that, but and so the first part, we're going to start in the ice core archives in Canada. So that's the repository. When you extract ice cores, They get stored in national repositories, and then scientists can request little pieces of ice. So this image that we're seeing here, that's an ice core. So these things are many kilometers long. The longest ones, of course, are Antarctica and Greenland, and then they're shorter in the Canadian Arctic, or they also have European glaciers. There's ice coring in the Russian archipelago, also by Norway and Svalbard. So the Japanese are involved, and the Australians. So there's many ice coring communities around the world, but when those ice cores are extracted over periods of many years, so a core can take 5 years to, if it's a deep core, it takes 5 years to pull that out. It comes up in meter sections. As I said, it's like almost 2 kilometers. Very expensive to do, but then they're actually marked up as well, and they'll be cut up, and different scientists that measure different things request chunks of ice from their national archives, and then this ice travels to different labs all over the world where it's melted, crushed, et cetera, et cetera. So we're going to begin at the I'll show you a clip from the very beginning of the project, which is more like a trailer. Oh, sorry, and this is just me holding an ice sample from Antarctica that's about 30,000 years old. And you can see, I mentioned air bubbles. You can see those little air bubbles. So this is what really is probably the most kind of unique feature of ice, is the fact that there's a material record contained directly within that that sort of material that scientists are then going to work to get out. So I just want to give you a sense of the visual language that I'm developing and sort of acoustic. So what we have in this opening sequence, you really have the transformation of ice from frozen material to something that's granular, to something that gets converted into a gas, eventually becomes digital information. It's scanned, and then it becomes sort of, as I said, digital. So that's this short kind of opening sequence. It's and as I said, this is a 3-part project. So the first part is a documentary. The second is a field school with Nunavut Arctic College. And the third part is an ice law forum around the right to be cold. So let's see if there's, and then we're just going to peer into the archive a little bit, and then I'll show you another clip. In 2011, the Geological Survey of Canada's ice core collection faced an uncertain future. Comprised of more than 1,000 meters of ice, drilled from glaciers in the Canadian High Arctic over a period of 4 decades, the cores and the scientists who worked on them were met with shifting research priorities and budget cuts. The prospect of thousands of years of climate history literally melting away spurred glaciologist Martin Sharp into developing a plan to save and rehouse the collection. The Canadian Ice Core Archive, now at the University of Alberta, shelters this unique collection of historic ice. Actually, let me just see if there's, yeah, I'm going to go to my next, I want to show a little bit of the next clip. This next little bit, the project is like, it's over an hour, so it has a lot of different sort of sections. Since 2017, the UNESCO Ice Memory Project has been extracting cores from endangered glaciers, especially from subalpine and tropical mountain regions, and transporting them to Antarctica, where they're preserved in the natural server farms of the pole. So here, actually, I'm saying quite a bit. A vast data set of vanishing information, now stored in the material memories of ice. As a teenager, I saw the snowy peak of Kilimanjaro every day from our home in Liumungu, Tanzania. But today, the mountain's glaciers have almost entirely disappeared and will soon only exist within their distant sanctuary in the Antarctic. It's a shame I've got that bar showing. Oh well. In 2009, Martin Sharp submitted evidence of global warming to the Intergovernmental Panel on Climate Change. Not in the form of graphs or images, but a field recording of the Belcher Glacier on Devon Island in Nunavut, an acoustic lament to the accelerated melting of Arctic ice. So Martin Sharp, one of the scientists, he sends an audio recording into the IPCC as evidence, and then this is where I was filming in the summer, and this is one of the world's fastest sort of melting glaciers, which is the Columbia ice field in the Rocky Mountains of Canada. So it's not a high Arctic glacier, but you can really start to see the kind of the ways in which carbon is obviously, these are carbon deposits in ice. So part of the project also went into the field. It dealt with the UNESCO Ice Memory Project, as I mentioned there, and I did spend my teenage years living in East Africa and Tanzania. So tropical mountain glaciers are being cored The ice from tropical mountain glaciers and subalpine glaciers is being taken out and stored now in Antarctica. So in 20 years, the only place where the snow from Kilimanjaro will be in Antarctica. So the project also, so it looks at many things, including the production of artificial cold. And then it moves from the archive, which we see, to the geochemistry lab in Oregon. And this is a very sort of famous lab because of the people working there. They happen to be working mostly in Antarctica. I'll show you a little bit from the lab.
Whereas the laboratory is the domain of destruction, the site where ice is cut, crushed, and melted so that its internal life worlds can be released and studied.
Maybe I'll just back up. This doesn't make...
Where cores lie in The archive is a space of preservation, where cores lie in purposeful wait. Whereas the laboratory is the domain of destruction, the site where ice is cut, crushed, and melted so that its internal life worlds can be released and studied. At Oregon State University, scientists and students are investigating changes in the chemical composition of air, especially carbon dioxide and methane, searching for atmospheric clues captured in the annual layers of snowfall that have slowly compressed to form polar ice.
Just maybe a little bit of a glimpse into the lab, which is a much more like dynamic, kinetic space compared to the archive. Sorry, I just wanted to, maybe I would just show a tiny little bit of Ed.
I think you can see that there's a lot that's involved in making the measurements. So we start out with the piece of ice in the freezer and we look at it and think about it. And sometimes really takes some time to reflect on it because the material is so interesting. Once you get it inside one of our chambers, our objective is essentially to destroy it. We want to get the air out. And all of the ice recedes a little bit from view because we're just now focused on the measurement and so on. But I think when we come back, once we have the data sets, I think our perception changes again because then we start to realize how unique the result is. We really are laboratory focused. We spend most of our time on the lab end. But collecting samples, I think for earth scientists, being in the field to collect the samples you're working on is really critical. And also for a lot of us, being able to do that is one of the reasons we like our work. Although we don't spend that much time in the field relative to the time in the lab, it's really important to understand the context that you've collected the sample in. Even if it's a deep ice core that's been drilled for 5 years and 50 people worked on it, it's really important for people to go there and understand how the material came into our hands and how we kept track of the depth and how certain we were about where it came from and all kinds of things like that. So everybody that works here gets to spend some time in the field, even if they don't really need to, just to make sure they have the whole picture.
Yeah, and then the project just then ends in Nunavut with a Mount Oxford, Nunavut, which is in Canada. And Allison she's an ice core scientist, and this is a very almost like DIY ice coring system. It's not like the big kind of infrastructures you would have in Antarctica. This is it's a two-person sort of kind of operation. So it's a much more sort of shallow drill, but to work where they need to work in the Canadian High Arctic, you have to be a mountaineer. You can't bring in a big kind of team as they do in, say, Greenland or in Antarctica. It's much more of an artisanal practice. Anyway, I'm going to leave it there. So that just gives you a sense of the ways in which I'm trying to conceptualize the relationship between environmental materials, questions around justice, accountability, sometimes legal questions, but also all the different ways in which these kinds of environmental materials can tell us different kinds of stories, and in certain cases can actually provide kind of evidential truths about our current kind of climactic or kind of planetary kind of tradition, or not tradition, condition, pardon me. So I just wanted to finish there. I'm happy for that to sort of play out, but maybe we could just turn the sound down, and because that's quite a long kind of sequence. And if anyone has any questions, I'm certainly happy to answer those as well. So thank you very much.
Поднимите, пожалуйста, руку, мы передадим микрофон. Вопросы, комментарии, пожелания?
Thanks a lot for your presentation and for your talk. Can you elaborate a little bit on how are you going to approach the work with youth of Inuit people?
Sorry?
With Inuit people, young people, how are you going to work with them?
Okay.
What do you expect, and so on? Thanks.
Yeah, that's a terrific kind of question. So in this case, I'm working with a team of like First Nations, both the curator, Candace Hopkins from the Toronto Biennial, is First Nations, and then people in the community. Two things. One is that when climate scientists go into Indigenous communities, at least I can speak for only a little bit about the Canadian context, they almost always only talk to elders and hunters and government officials. So when a climate scientist goes into the Arctic and into the north, the people that they talk to are always the sort of elders of communities. And yet young people make up the biggest kind of population in the north. So part of the project is, and this is one of the kind of criticisms of the ways in which climate scientists interact with Indigenous communities. They also tend to go in the summertime rather than the winter, when the climate is more kind of amenable. So part of it is to, and because I teach and I work with young people, that's my day job, in fact, and it's something that I really enjoy. So, of course, we're working with translators, and I'm bringing some students from Goldsmiths, and the plan is actually to do sort of more like a kind of acoustic kind of mapping. I'm sure it's the same here in Russia, but Indigenous communities are also subject to a lot of policy decisions and reports and surveys, etc. There's often a very kind of sort of forceful kind of institutional framework that enters into Indigenous sort of life worlds through things like filling in one more report, or or an anthropologist or a scientist sometimes wanting to sort of tick off boxes. This is a big problem, actually. Alison was saying that most ice core scientists, they have to do ethical reviews of their research, and they'll tick these boxes, but they're not sometimes that interested in actually engaging with Indigenous communities. So, I mean, my plan and my hope is that we work very much with these young people through the collaborators that I've set up, and that we try and produce some sort of almost like not a counter mapping project, but working with acoustics, and to really try and maybe tell a different stories of environmental change through the sort of sonic register as opposed to kind of visual. So that's the plan where it sits right now. And so I'm just sort of trying to also raise enough funding to make that happen and bring the different sort of groups of students together. Yeah.
Еще вопросы?
Hi, Susan. Thank you for your amazing talk. And I have a question. Can you please tell us more about how you work with the sound? Like, how do you proceed with the sound?
With the sound. Another really great question, because something, what I've been trying to do more and more is, as I said, is in some ways to use sound to denaturalize landscapes and environments, but also explore the ways in which sounding technologies are used a lot. A lot of sensing technologies like sonar, etc., they are sound or acoustic kind of based. In the case of this last project, I was working with many different kinds of microphones as well to see whether I could actually capture different kind of realities through the use of different sort of microphone technologies. I also worked with a really interesting Lebanese musician, Mohammed Safa, and so that's the first time I worked with a musician to produce. So it's not a sound design, and there's a lot of as I said, the piece is quite long, and there's a lot of kind of like, there's actually a sort of musical score. So that was an experiment on my part. I just gave Safa them visual materials and to see what he could come up with. And I think, so that's actually a bit of a different move. The music isn't like a direct consequence of what the acoustic properties of ice, for example, or the lab. The music is a supplement, but the music in some way, we tried to develop sonic signatures for different behaviors of ice. So when you hear certain sounds, it's a clue that you're in this kind of world or in this kind of moment. So to use the sound to have, as I said, so different materials have sort of signatures, and you can start to understand what's at stake. Now, one thing I should say is I played you, I realized bits were actually, I ended up doing a fair bit of talking, but the majority of the over out, like maybe there is about 6 minutes of me talking in total, but you happen to hear a lot of that. So other parts are just more the kind of acoustic properties of the materials themselves, but and then I always produce a sound design for my projects. I'm quite a sort of low-tech person in the sense that I do the editing and most of the sound design for projects, and and then I try and work, with collaborators where we can sort of have a shared conceptual sort of sense of a kind of project, but it's a very small scale and sort of general, yeah. And really trying to push the sonic dimension more actually than the visual, in fact, in my case, to somehow get us somewhere where the visual can't take us fully, yeah. Some sort of other kind of perceptual state, yeah.
Еще вопросы?
Anything that doesn't make sense, I'm happy to answer that as well. Maybe one thing I would like to say is that, and maybe I was going to say that, and you perhaps can relate to it, but I think within the context of, it was strange when I moved from Canada to the UK because all of the discussions around environmental change and climate change and global warming are really focused on countries in the so-called global south. And even all of questions around colonial kind of activities, et cetera. And that was a very strange sort of encounter for me, coming from basically a cold country and with a kind of very significant history of the colonization, a settler colonial nation in which, there was a genocide against its Aboriginal peoples, and moving to Britain, in which all of the debates were focusing south, not north. So in some way, I found myself sort of returning to Canada and really wanting to sort of locate discussions around environmental change in the context, and also colonization within the context of the North, because that somehow was part of the discussion when I lived in Canada, but not so much the ways in which the discussion tends to unfold in the UK for some. I'm not sure exactly why that's the case, but it's sort of shifting focus to northern states, and it's actually in some way much more, I would say, interesting in quotes, because unlike the South or a place like Antarctica, there's competing sovereignties in the North, there's rampant resource extraction, there's a kind of geopolitical set of actions happening. There's, all kinds of things happening in the circumpolar North that are a very kind of rich field of investigation and exploration as well. So that's sort of part of my sort of motivation in sort of embarking on this kind of project now.
Susan, I just wanted to, comment or ask at the beginning of the talk. By the way, thank you for the brilliant talk. You said that you quoted, I think, a scientist that said we can only.
No, Aldo Leopold. Yeah,
sorry.
Yeah. He's an environmentalist. Yeah.
You said that he said something quite radical, right? So we can only be ethical to that which you can see.
That's right.
And
yeah.
you said that you have been thinking about that. Can you expand a little bit more? What maybe how are your thoughts, to what have they arrived in relation to that?
When he said that, I think it's very true in the sense that, part of the work that I do with the students in the Center for Research Architecture and the work that I did when I was more actively involved with forensic architecture was investigation of human rights violations. And we can see the ways in which almost all NGOs, Amnesty, various organizations, they really require images of injustice for public advocacy purposes, in order to prompt kind of intervention. The image plays such a crucial role in responding to injustice. But there's a lot of injustice, like financial crimes, algorithmic kind of modes of governance, environmental. There's a lot of harms and violations that actually don't produce images. And in some way, I think that the fact that there's not a kind of image regime that's attached to specific, eventually consequences emerge, and you can see people losing their homes, of course, because of, let's say, financial speculation, and that certainly, and they're human subjects, and that could be documented and is. But the point, I think, is if our only response is we have to see an image of something in order to have proof such that we then sort of intervene or respond, I think it's very kind of limiting in terms of how we respond to the kinds of challenges that we sort of face. And that's why, I think there's many sort of thinkers, artists, writers, etc., that have been trying to understand the sort of, or try and at least challenge the sovereignty of the human being as the kind of, worlds organized entirely by kind of like human preoccupations, etc., and to consider, like they say, the more than kind of human, etc. But even I think I agree with Aldo Leopold, and Marx said exactly the same thing. He said human beings only think something is a problem when it's a problem for them, right? You really see that sort of friction does emerge in the case of the northern communities that have understood for many decades the fundamental changes that are taking place in their immediate environment and sort of habitat, but it requires a certain kind of, but somehow their own experiences and knowledge and stories sort of are insufficient for action. It requires some other kind of sort of representational regime, I guess. But I would disagree with his maybe provocation as well, because I think we can see that there's, so many examples, more examples where we might have an image of an event where it's very clear that something has happened that is deeply, deeply problematic and wrong. That's no guarantee of justice. So, I mean, there's so many examples of, especially in the age of citizen journalism, right? And, where we can see all kinds of grave violations captured by media, and that's not going to result in any kind of justice either. So I think in a way, I do think that Aldo Leopold, in saying that we can only be ethical in relationship to something that we see, I think there's a degree of truth to that, but that ethics of being confronted by something that we see certainly doesn't translate, or that confrontation or that which we see doesn't translate into actual sort of justice or of any kind. So there's also, I think there can be a very kind of misplaced conviction in the power of the image to disclose injustice and then to produce kind of political kind of change. But it is kind of the bread and butter of NGOs. Yeah, for sure. Yeah.
Thank you. If there's no, еще вопросы? Sorry. Сейчас, подожди.
Hi. Okay, thank you very much. And you mentioned, do you also interested in temporal gaps?
Mm-hmm.
And I'd like to hear more about that, and also maybe some other aspects which are interested in regarding time and connection between time and ecology and something like this.
Yeah, and another, I think, super question. Like for me, the gap, and the gap for me is the sort of, in my work, has been the sort of space of politics, or the gap is in some way what allows us to see the sort of politics of the event. So at least that would be my argument with the piece that's on display here and now in the museum, is that in that gap between that temporal gap of 19 days between the event and a kind of official public kind of acknowledgement that a major nuclear accident took place at Chernobyl, in that gap, if you start to read all of the activities that are happening, you can see the ways in which decisions were made not to distribute iodine tablets. A whole set of decisions were made, and I think that so I have argued that gap is then the space of the kind of political. We see politics working in that sort of interim sort of space, right? So I often feel that the lack of evidence for something can actually be more productive than when you actually have evidence. Like when there's an absence of something, that absence is perhaps can tell us more than if something was like fully kind of present, because then we actually start to investigate, why is there an absence? Why is there a gap? Why has this document been redacted? Why is there a gap in the historical record? And you enter into those kinds of holes or gaps because information of some kind, perhaps it's sort of missing, it might be kind of missing, or it might be willfully erased, because I've worked on other sort of gaps that are consequences of, say, erasure of like tapes and things like that. So those, when we encounter those sort of voids, they could be kind of temporal or acoustic or otherwise, when you enter into those voids, I think you can start to unfold a certain kind of politics that sometimes weirdly enough, it produces a kind of, let's say, visibility of an event precisely because the absence always throws up a whole set of kind of questions, right? And I guess in terms of time, I don't have, I guess it's I think that with the nuclear, I was very, like for me, that's probably kind of one of the most kind of powerful aspects of the nuclear. Also with the contaminants that take so many years to cross the Pacific. That's because there's a sort of delay. There's an event and then its effects that take, in the case of, say, Fukushima, 5 years later, you have massive spikes in radioactive readings off the western coast of Canada, and I guess eventually down into the United States. That gap is really kind of significant because oftentimes, like, emergency response is only dealing with the sort of immediate aftermath of the event, right? And so that event in some way remakes itself 5 years later in a very different way through these massive sort of spikes in, as I radioactive contaminants off the coast of British Columbia. And along the way, those 5 years, all kinds of other things have happened, like marine mammals and different kinds of marine communities are sort of affected, et cetera. So the gap is also, when it comes to nuclear events, that sort of the extreme temporality of nuclear materials often means that there's a kind of, first of all, it's a huge challenge in terms of how you deal with an event that might actually not fully kind of disclose itself until some sort of indeterminate kind of future. How do we actually respond to things that have yet to happen, or have happened in the past and are continuing happening, or they appear in unexpected places? I think there's it's an interesting is the wrong word, but it's a kind of important path to sort of follow, because it reorganizes the field and produces, I would say, makes demands to do politics kind of differently and to think about risk differently. And when you have those so for me, that 5-year period of those radioactive isotopes moving through the world's kind of oceans, and they continue to move through the world, they just get more and more dispersed, but there's a very specific current that runs from Japan to Canada. So there's a really kind of intensification that happened. But there's molecules continue to kind of circulate globally. So it also, I think, opens the field of accountability as well, that it expands the field. It makes it, so in that sense, it also redistributes or extends, like, who's implicated, who needs to be responsible. So I think it shuffles things in many different kinds of ways that is both deeply troubling, but also kind of productive for investigating.
Thank you very much for the talk. You were talking about the power plants and about mines, for example, urine mines. Is there any difference between what you told and, for example, bombs, nuclear bombs that exploded in Hiroshima and Nagasaki? Do you think there is still this aftermath of this bombing? And is there any evidence of the consequences that are maybe evident now, coming to the surface now?
When it comes to detonation of nuclear materials, of course, different radioactive isotopes have different different half-lives. So some of them, strontium, plutonium, etc. So the one I focus on, one of the more common ones that has a 60-year lifespan. But of course, there's some that have many, many thousands. And so, the nuclear tests. Let me answer this question maybe a bit differently. Yeah, this straightforward answer is yes, of course. There's all kinds of contaminants from the nuclear tests and the atomic bombs over Nagasaki and Hiroshima. Some of those radioactive isotopes still endure. They don't all have the same kinds of maybe we don't encounter them in the same sort of concentrated forms, or they may not necessarily produce the sort of same effects. Now I've just blanked. I was going to say something. My goodness. But this is what was really interesting, which I didn't mention previously. So when the Americans were doing all of this testing in the South Pacific, a lot of them, so cesium-137 was produced. It can only be produced by a nuclear reactor. It's an anthropogenic radioactive isotope. It can only be produced by the detonation of an atomic bomb or by a nuclear reactor. So when they found cesium-137 off the coast of Canada in 2015, they knew there was only one place in the world it could come from, and that was Japan, because more than 60 years had gone by from the time of the atomic testing in the Pacific, in the Marshall Islands, etc. So the Americans were doing all kinds of testing in the Pacific, but those radioactive contaminants decayed. So when they reappear, that's what's so unique about radioactive. There's a signature carried by those molecules. And so in this case, the testing from the 40s, more than 60 years went by. So those radioactive isotopes didn't exist anymore, but we knew that a massive leak of cesium-137 happened at Fukushima Daiichi. So, basically it was proof that those contaminants in the Pacific Ocean that are coming towards North America could only have come from Japan. So I was very interested in that story because I thought, this is an example where you can actually link the accident to the effect. Because in most cases, you can't link cause and effect when it comes to, as you mentioned, mining, or you can't link, it's very hard to link contamination from a gold mine to health effects in a community downriver. You can't prove that. You can say it's sort of likely. But with this radioactive isotope, they could say there is only one place in the world it comes from, that's Fukushima. So it actually, in a weird way, it has its uses in that sense, the signature of radioactive isotopes. So that's just to sort of maybe expand on the kind of point that you were making.
Друзья, нас уже немного поджимает время,
Sorry,
поэтому
we
если у вас
are
вдруг
out of
остались
time, so
вопросы,
if
вы
you
можете
have any more
задать их лично.
questions,
Susan,
please
thank you
come
so
up
much.
to the speaker. Thank you very much.